So without further delay, we will start today's session. Welcome everyone to the NPTEL course on the live session for environmental chemistry. I am Shaptarshi Bose here, a PMRF research scholar from IIT Madras. We'll discuss few numerical as well as some conceptual questions in this session related to the week 3 lessons which you got. So we'll move to the first question. I request everyone try to solve and write your answer in the chat section or the message section. This is a matching type of question. If you understand the basic formula, the basic equation of the reactor, you can solve this. Just a minute. Okay, let's go to the answer. No need to wait anymore. So the correct answer will be B, because in this equation you can see that this is the basic equation. So the V dCdt, which is the mass accumulated.
Yes, yes. I have done this.
Okay, okay, yeah, okay, thank
Mass accumulated, QICI, mass flow rate coming in,
ah,
Q0, C0, mass flow rate going out, and mass flow rate
okay,
coming,
okay,
mass flow
yeah,
coming.
okay, right, right, okay. So I'm just saying because this will is going to be recorded, so other students may. be benefited. So that's why I'm repeating your answer once again. So you can see that the V multiplied by dc and dt, that will be mass accelerated with respect to time, and then this is the inflow rate qi and ci. So this is the concentration and this is the flow rate. So I'm getting the mass flow rate here incoming, and similarly the outgoing I can get with respect to this outflow concentration and outflow flow rate of the water, you can say, and this is the mass formed or consumed, you can say, depending upon what is your reaction, like this is the final rate and this is the production and the loss, you can say. So depending upon that, how much is getting produced and how much is getting consumed, you can write this, right, with respect to obviously volume. So this is the next question. This is a connected question. So data will be same for question number 2 and 3. Please go through it. So we have one carcinogenic compound X present in the water, which undergoes decomposition in this completely mixed flow reactor. If this is the reaction, you can assume then the inflow water rate is given.
That means CSTN. Is it CSTN?
Yes, 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 yes.
That is start tank reactor, is it?
Yeah, yeah. Yes, yes. And also there is volume. You can see that raw water contents. So volume of the tank is given, inflow rate is given 2 meter cube per day, and the concentration are also given for X and Y compound. So rate constant is given, that is K is 4 day inverse. And there is another important information, that is the molar mass of compound X equals to 0.5 multiplied by the molar mass of the compound Y. So you need to calculate what is the concentration of compound X in the effluent.
Would you please tell what will be the equation used for the continuous start tank reactor?
That I will tell in the solution section. That will be better. So you can try, if you have the notes with you, you can just check, or otherwise wait for a few minutes, then I'll go. Okay.
Actually, the note is not whatever the lecture session is going, that is not properly understood.
So let's go to the solution. So I want to move further. So we'll be see. Please check the numerical uh, solution because there might be some error with the calculation. So I always say to check by yourself. So this is the inflow rate. You can say it was given that 2 meter cube per day, and the rate of the decay was also given that 4 day inverse. This is the rate with which X was converting to Y. And then there was something was given as this inflow concentration rate, that is 500 mg per liter for X and 10 mg per liter for Y. So here 0 means the initial one, you can just check like that. So that is the notation for here, 0 or not. So this is for the Y concentration. Initially it was coming, and this is the volume, that is
Or
500 liter, right?
zero is the initial or IN will be used.
Sorry.
Here X zero will be used or XIN will be
Yeah,
used
you can
initially.
use, yeah, you can use, like you can use IN. Yeah, I used
Because
not.
here you have used QIN. That's
Yes.
why I'm asking. It
Yeah,
should
yeah.
be XIN.
Yeah, you can go for XIN, no issue. Like this is for I checked with. I'm not concerned here with the outflow, but it can be confused. What you are saying that you can be confused with the outflow and other things.
Yes.
So it's better you can go with him, no issue. So or it might show you like that as zero condition, like when it was initial condition. So
How you have determined theta?
theta, right? So theta
Thi-
is H at T, right? So
Theta,
see,
theta is
yeah,
equal
yeah.
to
Yeah. I'm saying just let me share. Okay. Just wait. I'm going there. Just let me say because I'm not only answering for a particular thing. Actually, it's being recorded, so maybe other students will say later bit. So that's why I'm going a little bit slowly. So volume. What I was saying, the volume is given. You can convert it in meter cube, right? And then the theta. So how I'll convert theta? Theta is nothing but C. Theta is nothing but V divided by Q, right? So this is the volume, meter cube, it was here, and it was in meter cube per day, right? So that will give the HRT. How much time? That is the hydraulic retention rate time. Sorry. So hydraulic retention time HRT I am getting to here. So how long this much of water, this volume of water is staying inside that reactor, right? So this is how I am getting V divided by Q. That is giving us the HRT, right? And then we'll go for this complete mixed flow reactor. This is very simple equation. If you just go through your lecture, you will get to know how I got this. So C, after some time, after my required time, what was given here was this simply. Uh, okay, what will be the effluent, right? So yes, I can get this time from here. That is the HRT. That long the water stays inside the reactor, right? And this is the rate. With this rate it is getting decayed, or better to say it is forming X to Y, right? It's going to X to Y with this rate. With this rate, the rate is given for day inverse, and I got the time. So I'm multiplying with this, and this is the initial or with which concentration the water is coming. This is the X concentration, 500. I'm getting the final concentration 250 mg per liter. So I'll go to the next question. It is a little bit similar with the same data which I earlier said. So what will be the concentration of the compound Y in CSTR after 3 hours? So now I am asking for Y, not for X. And the time is mentioned here is 3 hours.
Would you please show us the initial
Ah, yes,
question number two?
yes, sure.
X.
Okay, so let's go for the solution. So answer will be A, that is 510 mg per liter. So how we are going to solve this? See, first of all, the time is given in hours. You have to convert in day. It's very easy. Then what you have to do? Suppose there was how much CX, the initial compound, which was the carcinogenic compound, right? X is the carcinogenic compound. So what will be the concentration of X after 3 hours? We have to first calculate. This is the similar equation which I used here, nothing else. So you can just write Cx and Cx naught, which I used for initial one. You can change with IN, no issue. Then write 500, and then you know the rate, similar rate for day inverse, and then the time which I have calculated. That is 0.125 day, right? And you will get that much liter, 333.33 mg per liter of the concentration of X is present, right? Then what you need to do is, suppose the whatever is converting from X to Y, that will be equal because the mass, total mass is equal, right? And one more thing you have to take care of here, that this is with respect to the molar mass. So everything should be in with respect to molar mass. I will request everyone to go through the lectures. You will know it's in the unit 3, so you will know why I am saying this. So everything should be in the molar mass format. And this is the stoichiometric coefficients used for X and Y. And if you go through this, the equation was given. So this, you can get what is the stoichiometric coefficient here for X and Y, both, like not only X and Y. So what you are doing is this. This was the, and this was also given. What is the relation between the molar mass of X and Y? So you can convert this into any of X, either X or Y. So just you have to write there. So it will be cancelled out, right? So 500 was the initial. Now after 3 hours, that is 333.33. So now we can see that, and we are getting this CY minus 10, right? And then here, what I have to write, that first the stoichiometric portion, that is nothing but 1 in case of X, and in case of Y, that is 1.5, right? See here is 1 and 1.5. This was the stoichiometric coefficient, and then you have to convert it, right? So X and Y, there is a relation 0.5Y. So I'm writing 0.5Y and here Y. So Y getting cancelled out, and you can get what is the concentration of Y after 3 hours. That is 510 mg per liter. So it is getting increased. Initially it was how much? It was 10, right? Initially it was 10, and after 3 hours it is 510 mg per liter, right? So this is the solution of the question number 3. We'll move to the question number 4. This is another numerical question. So a reversible reaction. It is reversible reaction. Note it down. It's not irreversible reaction, but a reversible reaction. The batch reactor process. So A and B. A is converting into B, and again B can be converted into A. So the rate constant for the forward reaction is 0.5 day inverse, and then backward reaction is 0.8 day inverse. So initial concentrations of the compound A and B are given as 250 mg per liter and 1 mg per liter. Then the molecular mass of the compound A and B, that is 15 gram per mole and then 50 gram per mole. Now we have to calculate what will be the concentration of compound A at equilibrium. Just so let's go to the solution here. So the answer is 307.69, and this is the solution. So I'll again request you to everyone to go through the lectures. You will get how I got this equation. So CA is the concentration. Okay, after it's reached equilibrium, you can say, and this is the K, the backward rate constant is forward rate constant, then the concentration of the initial one. So here it was initial concentration 250 mg per liter and 150 mg per liter. We have converted into gram per liter. So that's why I'm writing 0.250 and 0.150. Then so I'm multiplying with how much it was given as K, K backward zero point 0.8 and K forward zero point 0.5, right? So zero point 0.8 multiplied with this and then zero point 0.8 plus zero point 0.5, we are getting into molar, right? And then we can convert into mg per liter. Did I miss anything? Oh, yeah. I think I have missed one thing here while typing this. Just that thing I am saying, please note it down and do by yourself that you have to convert this into this molar first, and then you need to do this calculation and then again convert it to mg per liter because you want the answer in mg per liter. So while typing, I think I missed here. So just convert this mg per liter into mole first. Do your calculation, get your answer in mole. Just convert it.
Then mole divided by
Yeah,
how you are getting this mole divided by molecular mass, not
yeah,
mass
yes,
divided.
yes, yes, yes. Yeah, see, this was given, was right? So let me show you this. For A, it was given gram per mole. For A compound, that is 50 gram per mole. So what you have to do here, 50 gram per mole. You are multiplying it after getting. I missed one step here. That's why I told you. So you'll get uh, in gram, then you can convert into mg. Right? That's a simple. Then multiply it with 1000, you will get in mg per liter. I think you got it. So this small mole getting cancelled out, then will be gram per liter multiplied with this thing, mg per gram, gram getting cancelled out, you are getting mg per liter. So I hope this is clear. Let's go to the next one. This is again numerical type question. So due to one accident, this is before the COVID-19 pandemic, some chemical called benzyl chloride is introduced into a small well-mixed pond which was used as drinking water reservoir, right? And the amount is unknown. We don't know how much it was initially. So now the state water authority told you to estimate how long it will take to degrade to the amount of 1 microgram per liter. And because lockdown, we missed first initial 5 days. So you're going after 5 days to take your first measurement, and you got the measurement as 50 microgram per liter. And then after 5 days again, you got a concentration as 23.6 microgram per liter. So now you have to calculate after how many days it will come into this batch, 1 microgram per liter. And always note few things, few important information. That is the clue here. It's a well mixed, small mixed pond. So let's go to the solution. So the solution is the answer will be C, that is 31 days. So this is the way how we can solve this. So C5 is the concentration after 5 days, because we went there after 5 days only. We got this, it was given 550 microgram per liter, and again after 10 days, 23.6 microgram per liter. So this is a well mixed bond, example of the batch reactor. Nothing inflow and nothing outflow is happening there. So for this batch reactor, I can use this equation, C equals to C naught e to the power minus KT. So K will be here, the rate, and the T will be the time. So here few informations are also given. Okay, so this is after 5 days and 10 days, and this is our required concentration level, 1 microgram per liter units. Right? So I can write the equation, two equations with respect to these data, that is 50 and C naught. C naught was initial, and e to the power minus 5 after 5 days, and with K, K will be same for rate is constant, we are assuming, and then 23.6 equals to C naught. That was initial concentration. We don't know that, that is an unknown concentration, e to the power minus 10K. So I'm again using C naught as for the initial concentration. So if you divide 1 by 2, then this C naught will be cancelled out, and I'll get this equation, right? So then there will be no need to know what was the initial concentration, and therefore we can calculate what is the K. Just do it with mn, and you will get log base. You will get what is the value of K, that is 0.150155 K inverse. Now again write this equation. Already I have used this equation in the previous solution. Just go through that, you will get. So this is nothing but in the same format. I just write its EXP respective. So just write it down here. This is the C naught here, and this was this. Uh, I'm getting this 50 and minus 5. So this is the rate. This is the rate. I'm getting K here. So if you just calculate here, you will get C naught as 0.0593.22 microgram per liter inverse. So we need to get the final concentration. How much final concentration we need? 1 microgram per liter inverse, right? So to achieve 1 uh, microgram per liter inverse, I will write simply this is 1 C. The same equation I am using, nothing else. C is C as 1. Then this is the initial concentration I got from this equation. So C naught, now I know what is the C naught value. This is 105.93.22 e to the power minus. I know again what is the K. Yeah. So just put it at the place of K. You don't know the time, right? So from here you can calculate T. So after how many days you can expect the concentration as 1 microgram per liter. So hope this is clear for everyone. Let's go to the next question. Is it theoretical or conceptual question? So go through it quickly and also it's related to Brown's Lowry acid base theory. So it is a widely used theory. So it applies in case of both aqueous and non-aqueous, or it is only applicable for aqueous. Then with respect to the acid, it is capable of donating proton H plus or the last one. According to this theory, acids are defined as compounds which are capable of accepting non-bonding nuclei.
See,
Okay, so the correct answer will be the B and C. First of all, it's only applicable for this aqueous solution, not for this aqueous and non-aqueous, because for non-aqueous it cannot be applied. And then this is the like easiest one, as it will give the H plus. So, so nothing else were here. So let's go to this question number 7. A particular industry needs fluoride ion in the water solution for chemical production, and the source of the fluoride ion available in the market is in the form of hydrofluoric acid HF. So what will be the ideal pH at which the industry must operate? Sorry, pardon me. So assume the pKa value as 3.17. This is a really conceptual question. Okay, let's go to the solution. So this B will be the correct answer because see here the B is 7.5, right? So the pH should be always greater than pKa, then this HF will dissociate. Right? HF will dissociate and it will form fluoride ion. So to so this is the margin, this is the limit. So we have to go beyond this pKa value to get fluoride ion. So only this one 7.51 is we want 3.17. So this is the correct answer. Same thing is written here. So pH must be greater than pKa. So again, similar kind of question, not similar kind of question, but this is based on the Henderson-Hazelbach equation. So acetic acid dissociates in the water in this format, H plus, and this COH is getting apart from it, CH3CO minus. So this is representing as CH3CO minus ion, and this is the H plus. Here, for in case of acetic acid, pK is given as 4.76, and the concentration of conjugate base and conjugate acid present after dissociation are given as 10 to the power minus 4.6 mole per liter and 10 to the power minus 2.8 mole per liter respectively. So now you have to calculate what is the pH of water solution. So let's go to the solution. So answer will be A 2.96. So we'll check how to solve this. So from the Henderson-Hazelbach equation, we know this is the basic equation, pH equals to pKa and plus log, and this is the conjugate acid and base. We can write with respect to that. So what will be the conjugate base? Base concentration is 10 to the power minus 4.6 and acid concentration 10 to the power minus 2.8. So you can see this was the acid, conjugate acid, this was the conjugate base. Why I am saying that? Because it can accept H plus ion. So we are saying this is a base and it can donate H plus ion. So this is the conjugate acid here in this equation. So conjugate acid, this is the conjugate base which can accept H plus ion. It can donate H plus ion. So you know what is the concentration of each base and acid. Just write it down in the respective places, and then you know what is the pKa for this equation for this reaction, that is 4.76. Just calculate and you will find it pH as 2.96 for that water solution. So this is for the next question. Which of the following acid is strongest at pH 8? And you can assume that equal concentration of all acids are present. So pK values are given with respect to acids. This is once again a conceptual question.
HOCl.
HCl is your okay. I will just suggest think carefully because I solved a similar question. So I'll go through this one. Yes, it was quite similar. Not exactly same, but it was similar. Concept was same. Okay, so the first answer will be the HCl. Yes. So because here you can see that uh, uh, am I correct or am I wrong? Okay. So this is the strongest acid, right? Because here the pH is greater than pK. Is it so? No, it's not right. Right? So the written answer is quite. This is my pH. Okay. Yeah. So pH is here. Right. Right. I was a little bit. So right. Your answer is right. HOCl because pH is greater than. Yes. This is 8. Yeah, I missed it. Yes, I thought it was something different. Right. So pH should be always greater than pK. So here my pH in this case only that is greater than 7.53. So I will get more number of H plus ions, right? So I will get more number of H plus ions because this pH is greater than 7.5 because in this case it will not give H plus ions. So it will not give H plus ions because it will not dissociate. So it's not about with respect to how much, but it will not dissociate. So that is the problem. The similar thing was here. So here also pH was greater than pKa1, right? That's why we are getting F minus. So similarly, it will give you H plus ion also. Same concept is here. Yeah, you are correct. So thank you for joining to these sessions. Thank you everyone. Hope you enjoyed this session. We'll meet on next Saturday, same time. Thank you.